Children play happily in and near their homes, but sometimes these familiar places can pose a significant threat to their development and even their lives. Chemicals in and around their homes and schools can accumulate in their bodies. And studies have shown that even relatively small accumulations of toxic substances can result in behavioral and growth defects. The National Institute of Environmental Health Sciences supports environmental health research. With that support, a team of researchers from the University of Cincinnati Medical Center is conducting a biomedical research program to better understand the toxic effects of low levels of lead on children. During a 5-year longitudinal study of the infants of 305 mothers living in areas of Cincinnati with high concentrations of lead in the environment, they hope to help answer some of the questions on health effects due to lead. Through blood samples, the scientists have identified area children with abnormal lead levels. The Cincinnati study was the first to report an independent inverse relationship between prenatal blood lead and birth weight at lead levels common in the general population of women. This finding suggests that the fetus may be exquisitely sensitive to leads. Other findings of the study showed that blood lead levels were inversely related to infants' mental development index at 3 and 6 months, and that these developmental effects are more pronounced in male infants and infants from the poorest families. Lead also exerts an indirect effect on infant neurobehavioral development through its effects on slowing fetal growth and delaying fetal maturation. And it indicates that lead exposure, which contributes to low birth weight, also increases the likelihood of developmental delays. The primary target organ for lead toxicity is the brain or central nervous system, especially during childhood development. The children in the Cincinnati lead study undergo a comprehensive neuropsychological and neuromotor battery of tests in an effort to determine the effects of both low to moderate prenatal and postnatal lead exposure on child development. Each child is seen by both a pediatrician and psychologist approximately every 3 months from birth to 6.5 years of age. At 4 and 5 years of age, the child is evaluated by an array of neuropsychological tests. The Kaufman Assessment Battery for Children is one series. This best measures the information processing capacity and efficiency of the left and right hemispheres of the brain. In this subtest, the child's sequential processing ability is evaluated by having the child imitate a series of hand movements demonstrated by the examiner. The child must mentally arrange the information in a sequential order. This test primarily assesses the child's information processing by the left cerebral hemisphere of the brain. In this segment, the child must duplicate a form presented to him by arranging a group of separate triangles into a complete geometric figure.
Here's some triangles for you. Make your triangles look just like this picture.
This is one of the KABC subtests which assess simultaneous information processing ability. The child must mentally organize the separate pieces of the form into an organized whole, primarily a right cerebral hemisphere function.
Very good job.
The KABC allows lead study researchers to more finely localize the area of functional toxic insult to the brain. Knowing this, we can begin to devise more effective approaches to treating learning problems which may be associated with chronic exposure to environmental pollutants such as lead.
Okay, Willie, we tested your hearing as just fine today. Willie, you wore these earphones, but now you're going to wear some different earphones. Have you ever seen big people wear these?
As another example, at 5 years of age, Cincinnati lead study children are administered a test of central auditory processing called the SCAN. Developed by Dr. Robert Keith, a lead study investigator, the SCAN assesses the ability of the child's central auditory nervous system to recognize common words presented under conditions of distortion such as muffling or against a noisy background.
Say the word is.
Ear.
Say the word thing.
Saint.
Good.
Say the word cat.
Cat.
Say the word his.
His.
These distorted conditions in many ways mimic the environments in which children must learn, such as the school classroom.
Say the word.
Children who have difficulty recognizing words under these conditions have auditory processing disorders which make it difficult for them to attend to, discriminate, recognize, or comprehend information presented auditorily, even though the child may have normal hearing. Lead exposure has been implicated in the delayed development of speech and language behaviors, and the scan will help Cincinnati investigators to determine if a toxin-related central auditory disorder plays a role in the development of such deficits. The Cincinnati lead study is interested as well in the relationship between chronic lead exposure and motor development. The investigators in the study use a comprehensive battery of motor tests called the Voynich-Osaretsky test of motor proficiency. These examples come from the balance subtest. Previous studies of lead-exposed children from Cincinnati indicated a relationship between chronic low to moderate lead exposure and deficits in the functioning of the vestibular proprioceptive system which controls balance. Constant body sway is normal in all human beings. This normal pattern of body sway gets modified when one is exposed to toxic environmental chemicals. Balance and body sway patterns have been explored in the Biomechanics Ergonomics Research Laboratory of the Department of Environmental Health at the University of Cincinnati Medical Center. Under the guidance of Dr. Amit Bhattacharya, the Balance Evaluating Test System, or BETS, has been developed, refined, and validated. BETS is utilized along with a specially designed testing procedure for detecting the subtle effects of lead exposure on children's balance. A microprocessor-based force platform technique has been developed, which can non-invasively quantify human body sway in 30 seconds. The test involves standing quietly on a force-sensing platform with eyes open, then closed for 30 seconds each. Next, the subject stands on a compliant or foam surface placed on the platform, again with eyes open, then closed for 30 seconds each.
Okay, now close your eyes this time. Nice and relaxed.
The test provides a real-time quantification of the body's center of gravity movement pattern. It also allows evaluation of various components of physiological processes relevant for postural control, such as nerve signals from the muscles, eyes, and inner ear. Computerized plots of the BETS results comparing a subject with high blood lead content and a subject with low blood lead content offers a dramatic distinction in sway pattern. This technique has been found effective in quantifying postural disequilibrium in children with a known history of lead exposure. Preliminary analysis showed a significant increase in postural sway with higher maximum blood lead levels in these children. Although headway is being made in identifying the effect of lead toxicity on childhood development, the at-risk category of young children and pregnant women are increasing in number. That is, as health effects are found at even lower levels of lead exposure, the number of potentially affected children and pregnant women increase. Lead poses a toxic threat for which there are no natural defense mechanisms, and no economic or racial subgroup of children is exempt from the risk of having blood lead levels sufficiently high to cause adverse health effects. The research findings by such NIEHS-sponsored biomedical programs as the Cincinnati Lead Study is of major public health significance. It's not a new disease. At the turn of the century, childhood lead poisoning of near epidemic proportions occurred in the state of Queensland, Australia. The stunted growth and weazened appearance of this child illustrates only one feature of the problem. 78% of the children in the series of 156 cases experienced paralysis of nerves controlling articulation of their ankles or wrist. Approximately 9% experienced severe brain damage, and many died of renal failure years later. The Queensland episode first alerted the medical community to the nature and severity of this environmental disease, and it pinpointed the importance of lead-based paint as a source of childhood lead poisoning. The Queensland children almost invariably lived in wooden houses painted with lead-based paint. The children often were confined to the verandas characteristic of the homes. Because of the extremely hot conditions prevailing in the subtropical climate, the paint was badly chalked to a fine, powdery film. The children transferred this powder to their mouths from their hands or by biting their paint-contaminated fingernails. The state of Queensland banned lead-based paints for domestic use in 1922. Although some cities in the U.S. prohibited the use of lead-based paint earlier, it wasn't until 1970 that federal legislation authorized federal agencies to establish appropriate regulatory actions. In 1923, a totally different but potentially important source of lead exposure arose. In that year, tetraethyl lead was introduced as a fuel additive. Dr. Robert A. Kehoe at the University of Cincinnati took seriously a committee's recommendation that research be undertaken to determine whether a threat to health might result from long-term accumulation of lead from gasoline in the environment and in the human body. From 1930 through 1960, he performed a series of studies defining the effects of small daily doses of lead on its accumulation in the human body. He documented the doses taken by adult volunteers, often over a period of 1 or 2 years. But when the phase-down of leaded gasoline was finally begun in 1975, the impetus came from reports and studies initiated subsequent to the Kehoe era. Numerous studies throughout this century have shown that children were far more sensitive to the toxic effect of lead, and the accumulation of lead from the combustion of gasoline posed a clear threat to the quality of human life, particularly among young children.
For years, scientists in Cincinnati have checked blood samples of area children for abnormal lead levels. Many times they found them. The research gave UC's Department of Environmental Health a reputation for leading the country in the study of effects of lead on child development. High lead levels affect kidney function, brain function, and the hormones that regulate growth. The lead comes from old paint, weathered or sandblasted off of homes, or the exhaust of cars that use leaded gasoline.
Not very long ago, lead was a basic ingredient in house paint. And when the contaminated paint was chipped off the house, the lead ended up in the yard where children could be exposed to it.
It gets in the soil. Kids play in that soil.
And the hand-to-mouth activity that is normal to children in the 12 to 24 months age in particular is the pathway by which many children receive lead into their systems.
Although lead-based paint and leaded gasoline are major sources of environmental lead exposure, they are not the only ones. People who work in an environment where lead is an ingredient can carry the hazard home to their families in dust particles on their clothes and their skin. Lead pipes in older homes and even the lead soldered joints in the plumbing of newer houses may deposit lead in drinking water. Water coolers in schools can even be a source of contamination. Areas of rehabbed housing can be an especially hazardous source of lead. Besides the deposition of paint flakes and chips in soil outside the homes, particles of leaded dust can become trapped in the home carpets and be transferred to small children. Certain pieces of pottery and household utensils may contain lead, which becomes mixed with the food prepared and served in these dishes. And leaded cans, especially imported foods, may leach lead into the food contents to be ingested at dinner time. Even the hobbies people choose may be a lead hazard. Shooting guns at a firing range or a stained glass hobby may deposit lead particles on hands and clothing and can be transferred to children. The health effects of lead toxicity can be devastatingly severe, or they can be subtle. A child can be growth impaired or suffer delayed neurobehavioral development. And there's no natural defense mechanism to protect our children. Continued study of the effects of lead toxicity